Hey guys, this is ScienceCraft. Welcome back to another video. And today I'm going to be talking about quantum superposition. First off, quantum superposition is when a particle, for example, an electron, is in all possible states. And we can show this very well using Schrodinger's cat. I don't know how to spell Schrodinger. I think it's a German word or something. I don't know. But okay, so this experiment involves a box. So there's a cat in a box. There's a cat in a box with a radioactive substance, with a poisonous gas in a flask that has, and then there is a hammer. Now this is a thought experiment. This was not an actual experiment that was performed in real life. This is a thought experiment. I need to fix my hammer. No. That's better. With a hammer and then there is a substance, and as soon as one of those atoms decays in that substance, it sends a signal to the hammer, causing the hammer to crack, to smash open the glass, releasing poisonous gas, killing the cat. Now the chance of one atom decaying in this substance is 50-50. So half and half. So that means that once you close up the box, and then you walk away, the cat is in a superposition of both being alive and dead. So the cat is in a superposition. But when you look in the box, you only see one or the other. That's because whenever you measure an object in superposition, if an object's in superposition, and then as soon as you measure it, what state it's in, it causes it to be forced down into one state. And now you're probably thinking, well then how do we know superposition exists if every time we look at an object, it's just in one state? Well, that's a good question. I'm glad you asked. So, again, it forces the cat to either be alive or dead. Not both. Not both. It is both, though, before you look in the box, but when you look in the box, it causes the cat to either be alive or dead. Dead or it's alive. So, now that we know that, and again, earlier, you asked me, well, how do we know superposition exists? If every time we look at an object, it is in just one state. I'm glad you asked. I'm going to show that using an experiment that was actually done in real life. It's called the double slit experiment. It's called the double slit experiment. So, here's how it works. You have a wall with a double slit in it. And then you send one item, for example, let's say you send an electron. You send a bunch of electrons through the double slits. You will and then you have a wall behind them. You will end up with a kind of pattern, I guess, that looks like this or something. And so then you send two things through the double slit. For example, let's say a proton and, for example, let's say a bunch of protons and a bunch of electrons. You send those through, starting with the the electrons. They go through, and again, you will end up with this kind of pattern. And then you send the protons through, and you end up with another sort of pattern. Like that. So, then we make it 3 slits. We send both the protons and electrons through at the same time. But something weird happens. Because when you do this, when you send through the electrons and the protons at the same time, this is what happens. So, let's say the protons go through here, and here, and here. And then the electrons go through here. And the electrons. So then you have the protons and the electrons, and then again, you end up with this pattern. But wait a minute. Right here, you have protons and electrons. So that must mean that the protons go through here. So if the protons go through here, I can show this better again. So the protons, wait a minute, I should draw on this side. Okay, so if the protons go through here, that means, and then that will allow a spot right there for the protons, and then the electrons go through, they also get a spot there. That would mean that the photons go through, and then they block the electrons, but then there's still some over here. So that would mean the electrons would have to go through, blocking the protons. This means they're actually in a superposition. And no, they can't go through each other. They are both, so let's say these are, I don't know, rocks. Rocks can't go through each other. So you would end up with something like this. And they would both be in a superposition of both being. They would be in a superposition of both being able to go through. That is quantum superposition. I hope you guys like this video. But wait, this isn't the only video for today. And be sure to subscribe, like, and smack that notifications button in the face. Bye guys, see you in the next video.